So let me go ahead and write this down, and I'm probably actually going to go ahead and even record this because I am sure you are not the only one having this question. Probably should have done the other one as well, but I didn't. All right, unshare your screen. Hold on. Yes, the one that I had you guys get is just a little bit better than that one, but that one's fine. All right, so the product rule has this, right? Now, does your book use f of x and g of x, or does it use u and v? Okay. Well, instead of writing f of x and g of x, I'm going to use u. I'm going to make all of this equal to u, and then I'm going to make all of this equal to v. It's the same thing, I just think the notation's a little bit better. So if you ever have any kind of function where it was y was equal to u times v, then the derivative of y is the derivative of u times v plus u times the derivative of v, which is what we're going to go ahead and do. It's the same thing as a chain rule, right? Because if it was f of x and g of x, I just think the notation is a little bit tricky. So if I take u, and like I said, we're just going to call f of x u. I just think it's easier that way. So then u is equal to 3x minus 1 to the 5th power. Then the derivative of u, or again, if you use a notation f of x, those two things are the same. Now I need to use the chain rule. So what I do with the chain rule is the 5 comes out front, and now I'm left with 5. Everything on the inside stays the same, and 5 minus 1 gives me 4. But I have to now multiply times the derivative of the inside, which in this case is 3x. All right? Now we're going to do the same thing with a v. V is the second one. And again, if you would prefer the notation g of x, it's the same thing. Yes. I do this, it's the chain rule or the extended power rule for the wording in the book. The 4 comes out front. Everything on the inside stays the same. So that is 1 minus x to the 5th. And then that just becomes 4 minus 1, or 3. But now I have to multiply times the derivative of the inside, or the derivative of this, which is going to give me minus 5x to the 4th. So all I've done right now is done the backbone of how to set the problem up. Because y is in the form of one function times another function. So this is my first function. This is f of x. And the second function over here, this is v. So because I have these two pieces being multiplied times together, now I take the derivative of both of them individually. Now I have to go through and use the product rule. So now for the product rule, I take the derivative of the first times the original of the second, which gives me 5 times 3x minus 4, 3x minus 1 to the 4th power times 3x. And I multiply all of that times 1 minus x to the 5th to the 4th power. Now, because it's the product rule, I add it to, and now I have it times the original of the first times the derivative of the second. So that gives me, 3x minus 1 to the 5th times, I'm going to run out of room, move this over here, times 4 times 1 minus x to the 5th to the 3rd times negative 5x to the 4th. And this is really messy, so I'm going to try to clean it up a little bit. So I'm just going to go ahead and multiply those two together, and I get 15x, 3x minus 1 to the 4th power, times 1 minus x to the 5th to the 4th power, plus, and I'm going to combine the 4 and the negative 5x to the 4th. So that's actually not going to be a positive sign anymore. I'm going to need to make that a negative 20x to the 4th times 3x minus 1 to the 5th times 1 minus x to the 5th to the 3rd power. And the GCFs when we're doing these are a lot more intense than what we had when we were in intermediate algebra or college algebra. So my GCF between 15 and negative 20 is just going to be 5. Then my GCF between x and x to the 4th, I pick the lowest exponent, which is going to be x to the 1st power. All right, now I need the GCF of all of this, 3x minus 1 to the 4th, and 3x minus 1 to the 5th. But remember, all we're doing is we're looking at what the exponents are. This is the exponent of the 4th, and that is the exponent to the 5th power. So your GCF is going to be 3x minus 1. I picked the lower exponent on the outside, so that would be to the 4th power. And I do the same thing again with the next one, and that would be 1 minus x to the 5th. And what exponent would I want on that one? Yep. Once I pull that GCF out, my GCF is 5x times 3x minus 4 to the 4th power times 1 minus x to the 5th to the 3rd power. Oh, sorry, excuse me. That should be 3x minus 1. I was just thinking to the 4th power. All right, so now what are you left with? So 15 divided by 5 is 3, and x divided by x is just 1, so that just becomes 3. Now, if you notice, the GCF here was 3x minus 1 to the 4th power. That completely cancels out with this one. And then here, this is 1 minus x to the 5th to the 3rd power. And if I subtract these exponents, 4 minus 3, that tells me I have one more of those left over, so that would be 1 minus x to the 5th. Now I do the same thing with the next one. 5 divides into negative 20. That gives me a negative 4. And then x to the 4th. If I pull out an x, which means I'm dividing it out, would leave me with x to the 3. And then the next one I look with here is this is 3x minus 1 to the 4th power. This over here is 3x minus 1 to the 5th power. So I have 1 left over. And the next one completely cancels out. So now to simplify all of this, this 5x stays the same, 3x minus 1 to the 4th stays the same, 1 minus x to the 5th to the 3rd stays the same. Inside here, I want to multiply this out. And then that gives me, if I distribute both of those in over here, then I'm left with 3 minus 3x to the 5th minus 12x to the 4th minus, plus 4x to the 3rd. And now, thankfully, I am done with this question, and you get to be 5x, 3x minus 1 to the 4th, 1 minus x to the 5th to the 3rd, and then everything over here, if I put it in descending order, would be minus 3x to the 5th, minus 12x to the 4th, plus 4x to the 3rd, plus 3.